This is Unit 11, Lesson 3, and in this unit we'll be working with logarithmic functions. You'll hear them often referred to as logs. Okay, so what is a log? Well, first of all, it is the inverse of an exponential function. Right, and we use them to solve exponential equations that when we can't find a common base. So back in Lesson 1, we solved all these equations by finding common bases. Well, we need to use logs to solve ones that don't. All right, so we will be using our calculator in this lesson. So please go ahead and grab one if you don't have it handy right now. We don't need just a second, but you know. All right, so a log function, it's the inverse of an exponential. So the first thing we're going to focus on is converting between logs and exponentials because we need to understand how they're related and finding inverses before we can go ahead and work with their properties. So when you see this, this is a log. The little b is a base and will always be written as a subscript, a smaller number. All right, so if I'm going to convert this, the b stays as my base, and then the a and the x switch places. So it ends up being b to the x equals a. Okay, so this ends up being my exponent, and it equals that. All right, so what we're going to do first is simply convert them, take them from logs and rewrite them as exponentials, and you'll see mathematically that it works out. So for example, in number 1, the 3 is my base, the 2 is my exponent, and that equals my number or my argument. And that's right? 3 squared does equal 9. Yay, go us. Okay, so if I'm going to rewrite number 2, once again, the 4 is my base. I'm raising it to the 3rd power, and that equals 64. And you can double check 4 to the 3rd. 4 times 4 is 16, times 4 again is 64. Here, 3 to the negative 2nd power is 1/9. But you know that's true because this ends up being 1 over 3 squared, which is 1 over 9. All right, to rewrite this as an exponential, 7 to the 5th equals 16,807. Yes, it is that big. This one, sorry, it was a typo. That should be 3 over 2. 9 to the 3/2 equals 27. Okay, if I take the square root of 9, that's 3. 3 cubed is 27. And now this last one. So here's something, there's 2 points we're going to make here. Okay, first of all, there is no little base written. There is no little number. Like in 5, we have the base of 9. When there is no base, that is called your common base. When there is no little number, it is 10. Okay, so no base equals base of 10 always. There's a log button on your calculator, and that will always do it in base of 10. We'll talk about that in a little bit. So this one is actually log base 10 of 10 equals 1. So when I rewrite that as an exponential, I'm doing 10 to the 1st equals 10. Okay, so there's 2 points that we're seeing here. First of all, once again, when there is no base written, it is 10 always. Okay, so you can rewrite the 10 if you want, or you can leave it out. You don't have to write the 10. The second thing to be aware of, when you're doing a log base b of b, and it doesn't matter what that is, as long as your b is greater than 1, okay, a base has to be greater than 1, that will always equal 1. So if I did log base 4 of 4, if I were to rewrite that as an exponential, it would be 4 to the 1st equals 4, which is true. So when you have, and we'll see this later too, but when we're simplifying, when these 2 numbers are the same, it will equal 1 every time. You can check that with any number combination that you want to, if you don't believe me. All right, so let's go the other way. We're going from an exponential to a log. So we're flipping it around. We're doing the inverse. We're writing as a log. So this is the base. The base is the same thing. It's always a number that's raised to an exponent or the subscript in log form. So I've got log base 2, and then the 16 and the 4 switch places. Equals 4. Okay, that's telling me that if I do 2 to the 4th power, I would get 16, which I do. It's true. This one is the same. Sorry. Right over here. So my base is 10. So when I write this as a log, I don't have to write the little 10 in. You can, like up here, but you don't have to. So this is saying the log of 10,000 is 4. All right. Log base 4 of 8 would be 3/2. Log base 5 of 1/25 equals -2. So the exponent moves over to the argument, the number on the other side. Log base 7 of 7 equals 1. So we see that happen again. When these 2 are the same, it always equals 1. And this is why 7 to the 1st is 7. It stays the same. Okay, so what we're going to do now is we're going to take that, now that we can convert between logs and exponentials, and actually find inverse functions. So what's the difference down here? Because look, if you look at each one, it's a y equals. I have y equals blah, 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 x, okay? So it's an actual function that I could graph. Up here, I could just solve this and get a value. All right, so remember, when we are finding inverses, first of all, they are reflections over the line y equals x, and we also know that our domain and range switch places. That's what a characteristic of an inverse. So in order to find an inverse, the same thing applies. I'm going to first switch my x and my y. So I have x equals, I'm going to, hold on a second, I'm going to write these below where I have some room. So I have x equals log base 4 of y. Now, if I have anything being added, subtracted, or multiplied outside the log is my function. I'm going to move that or undo that first, but I don't. So now I can go ahead and switch, write this as an exponential. The 4 is my base. This is my exponent equals y. Those are inverses. Once y is isolated, I have my inverse. All right. Let's do number 3 first. Number 2 has a little bit of a twist. All right, so for number 3, I'm going to switch my x and my y. Okay, I have nothing outside. That minus 4 is inside, so you don't need to move it yet. So we're going to go ahead and switch. Oh, sorry, that should be a y. So I'm going to go ahead and write it as an exponential. So 3 to the x equals y minus 4. And it doesn't matter. You can have y minus 4 equals 3 to the x. It's the same thing. Now, y is not by itself, so I need to move that 4. So the opposite of subtracting 4 is adding 4. Okay, since I already did the exponential, that minus 4 ends up being on the outside. So let's go ahead and take a look at number 2. Switch my x and my y. Okay, now nothing is being added, subtracted, or multiplied outside the function. That times 2 is inside, so we're going to have to take care of that later. So let's go ahead and switch. We write it as an exponential, so here's my base of 2. So I've got 2 to the x equals 2 times y. So now we need to move that 2, so we're going to go ahead and divide by it. However, it'll be much easier to see it if I write it as a fraction, meaning multiply by the reciprocal. So the reciprocal of 2 is 1/2. So if I multiply both sides, I get 1/2 times 2 to the x equals y. Now we always want to combine as much as possible. So if you notice, these two can be written with a common base. Well, they are both right, 2. Since they can be written as a common base, I'm going to go ahead and do that and combine them. If this fraction was like a 1/3 and I couldn't write them as a common base, I would just leave it as 1/3 times 2 to the x. But I can rewrite 1/2 as 2 to the negative first. And our rules for exponents are when they have the common base, we can just add the exponents because they're on the same side of the equal sign. So I've got 2 to the x minus 1 equals y. And that is the inverse. Okay, so that one looked a little different because I had 2 things being multiplied right here. So that's why that one was a little bit different. All right, we're going to go the other way now. We're going to go from an exponential, oh, I forgot what it said, 3 to the x minus 6, to a log. Anything adding, subtracting, multiplying on the outside? No, this minus 6 is up in the exponent, so I can't do anything with it yet. So we'll go ahead and we'll switch our x and our y. We'll take the log, okay? We're taking the log to move it out, move this out from my exponent. So log base 3 of the x equals y minus 6. So remember, in exponential form, whatever is with the base ends up being on the other side of the equal sign and vice versa. All right, now I move this. So log base 3 of x plus 6 equals y. All right, number 5. Y equals 2 to the x and then the plus 7. Okay, switch your x and your y. So I've got x equals 2 to the y plus 7. Now that plus 7's on the outside. It's not attached to the exponent, so I need to move it before I can switch it to a log. So I'm going to subtract 7 on both sides. Now I can rewrite it as a log. So I've got log base 2 of the x minus 7. Since those are attached, I'm going to put those in parentheses. Equals my y. Okay, so since the plus 7 in the original problem started on the outside, it ended up as a minus 7 on the inside. And my last problem. Got my copy, so I don't have to keep scrolling up. Okay, y equals 2 base 3 to the x plus 1. So that times 2 is on the outside, okay? So we need to keep that in mind. Go ahead, switch my x and my y. Take care of this. So divided by 2, let's keep it as a fraction in case we have things with common bases later, okay? It's easier to see in fraction form. So now I'm going to go ahead and I'm going to take my a log. So log base 3 of 1/2 x equals y plus 1. Oops, sorry. So log base 3, and we can keep those together. That was a plus 1, so I'm going to subtract 1. That's my inverse function. All right. Let's move on. Okay, so evaluating. This is kind of a continuation of what we were doing last class when we were solving exponential equations. We're going to learn how to evaluate by hand and using the calculator, okay? So first of all, to evaluate, we want to know what log base 7 to 49 actually equals, if it's a nice pretty whole number. And it is. So how can I do that? So first things first, let's write it as an exponential. So this ends up being 7 to the what? What is this equal to? We don't know. So for right now, we're going to put a variable there, whatever letter you want to use. So I'm saying 7 to the x equals 49. I'm trying to find out what that is. So log base 7 of 49 is the same thing as saying 7 to some power is 49. Well, if you know your perfect squares, you know it's going to be 2, but let's talk about why. So here's what we did last time. We said, okay, to solve this exponential equation, write them with a common base. Well, 49 can be written as 7 squared, and then when you have a common base, your exponents are simply just equal to each other. Okay, so that's why we can rewrite it as exponential and solve it. So for example, log base 3, I don't know why I'm rewriting that, sorry. I can rewrite this as 3 to something is equal to 81. We're trying to find out what that something is, okay? So from here, if you know the number, just write x equals 4, no big deal, but that's going to be 3 to the 4th, so x equals 4. Log base 2, here's that magical combination. It's going to equal 1. Let's take a look at why. 2 to something equals 2. Well, this is why this works out, because something to a, in order for it to equal itself, that power has to be 1. Okay? 2 to the x is equal to 2 to the 1st. 3 to the x equals 1/9. Okay, let's rewrite this with a common base. 3 to the x equals 3 to the, yeah, sorry. It's Monday. 3 to the x equals 3 to the -2. How did I get that? Well, 1/9 is 1/3 squared. Don't want to write it as a fraction, so it's 3 to the -1/2, or -2. So x equals -2. Okay, here's that other magical thing. So before we said log base b of b equals 1 always. Well, in this case, log base a number of 1 equals what? So let's take a look. So 7 to the x equals 1. Well, in order for us to do this, and you had problems on your last homework like this, I want to write this with a common base. Well, how can I write this with a common base? I can rewrite 1 as a base of 7. To what power? 7 to what power gives me 1? 0. Therefore, x equals 0. So whenever you have a log base b of 1, it will always equal 0. So that's the other thing to remember. Log base b of b equals 1. Log base b of 1 equals 0. And our last one, there is no number written, so that is our 10. Okay, so this is 10 to the x equals 1,000. Okay, that's going to be, and 1,000 is 10 cubed, so x equals 3. All right, now, our change of base formula. Lucky ducks for you, your calculator can handle this for you now. I want you to understand what the change of base formula is, but since you would need your calculator to compute these anyways, there's no point in not using that technique, and I'll show you what I mean. So change of base is what we do. Well, what happens when you can't find a common base? Like if I'm doing log base 749, what if it's log base 748? I can't rewrite 7 as a power of 48, so I need to do a change of base. All right, or I can evaluate it on my calculator now that they have that option, and I'll show you why I'm saying there's that difference there. But like this one, I have to rewrite as 2 to the x equals 54. Okay, but I can't rewrite 54 as a power of 2, like 2 to nothing, not a whole number will give me 54. So that's what we need to find. Well, what is that number? And if it's not going to go in evenly, you're going to get a decimal, okay? An irrational number, most likely. Not always, but most likely. So what you used to have to do, well, what they used to have to do is use charts and stuff, but then you just have to go on your calculator. Now your calculator, look for log, it's right here, okay? Log, sorry, let me remove that. When you hit the log button, it always will show up as a log of base 10. So when you see that log button and you type it in, let me clear out my screen, that's a base 10. So remember, when you don't see the number, 1 second, please. Okay, sorry, someone was at the door. Okay, so when you hit the log button on your calculator, it's automatically base 10. So there is a new way to get around that, but they didn't used to on like the TA83s. This wasn't there, which is why you had to do change of base. So I'm going to show you the change of base, but I'm also going to show you how you don't have to worry about that. So for change of base, what you're going to do is you can pick any new base you want. Typically, people will use the natural log, which we haven't done yet. We'll talk about that next time, or base 10. Okay, so I'm going to rewrite this with my new base. That's what represents the C here, my new base. So I would write that as log base 10, so I just write log of 54 over log of 2. Okay, and once again, the reason that people use base 10 or natural log is because those are the two options on your calculator. You have the log button, or you have, this is the natural log, and it really doesn't matter. I'll show you both ways and it'll work. So if I were to type this into my calculator and evaluate it, I have the log of 54. So it's always the, what would end up being the argument on the other side first divided by the original base. So the original base is always second. That's the easiest way to remember it. Okay, and I'm going to get some decimal. Okay, so that's what that is. So if I were to be solving it, that would be my exponent, 5.7548. Now, if I did the natural log, okay, and the natural log is the inverse of E. You learned about E, the natural base, last time. So its inverse is called the natural log, and it's represented by ln. And it's a value in here, and you don't need to worry about that. Okay, but it itself is a number. So it's using a base E. It's called the natural log. So anyways, if I use that as my base, divided by a natural log of 2, I should get the same exact thing, and I do. Okay, so, and you can just pick another number. Let's do log base 3. Well, you don't need to. Let me show you why. So this is what you used to have to do this way to get the 5.758, I believe it was, 48, something like that. This is what you used to have to do before the newer TI operating systems gave you an out. If you hit math and you arrow down or arrow up, it gets there faster, to log base, it allows you to type in any base you want. If you simply hit the log button on your home screen, it will not show up this extra little box to type in the base. So I want you to understand change of base. I want you to be able to write it out, but you don't have to use it to evaluate. Okay, so just understand about it. So my answer would still be the same. Okay, so once again, in number 2, if I were to go, and you can rewrite this as a common base, sorry, I'll pretend you can't, but if I were to go to evaluate this and I say, hey, there's not a common base, I would have to do log of 32 over log of 8. Okay, so what I want you to do is practice setting it up and then check on your calculator to make sure you can do it both ways. So log of 32, close your parentheses, divided by log of 8 should give me the same exact thing as if I were to go in and use math and get to my log base and type in base 8 of 32. I should get the same exact thing. So just make sure you can do both. All right, so it's 1.666. We'll do 4 numbers and truncate it, meaning just chop it off, don't round. All right, and the last one, I can do log of 294 over log base 10, which is really just log base 294. So type it in, or just type that in on your calculator. Now notice this one is a base 10, so you could just use the regular log button, because remember, that implies base 10. Or I can go in and I can do the log base and type in the 10. I should get the same exact number. Or, look at that. Or I can just do the base of change of base thing, and it should give me the same thing, because really I'm just dividing by 1 here. Oh, yeah. There we go. All right, so all different ways to do that, 2.46, whatever it was, 8, blah, blah, blah. Okay, so that's what change of base is for. So let's learn now some properties of our logs. We're going to use these to help us simplify and then eventually solve. We'll be doing the solving next class. Okay, so the product property, it states that when you have a log and you've got two values being multiplied, you can rewrite that as two separate logs using addition. So we're going to be asked to condense. Condense means write as one log. Expand means write out everything separately. Okay? So if I were to give you log base 3 of 5b. If I were to write that, if I were to expand that, it would look as log base 3 of 5 plus log base 3 of b. I could write them separately. All right? So we're going to flip to the next page and do some practice. We're going to do 1 through 3 because those are using that property. All right, notice all of them have plus signs in between. So first thing we're going to condense and we'll expand. So if I were to condense this, I'm writing it as one log. So I only want to see that word log one time. And remember, you can only do if they have the same base. So I've got log base 3 of 7 times 4. Since you can actually physically multiply them, go ahead and do it. So that's 28. All right, my directions say condense and write as a single logarithm, simplifying if possible. So without using our calculator, can I simplify log base 3 of 28? Meaning, does 3 to any power give me 28? No, so that's as simplified as it will get. All right, number 2, log base 2. 3x times 4x squared is 12x squared. Nothing else I can do. Number 3, I have 3 things, but that's okay. They're all plus signs, so I've got log base 4 of 5x times y times z. So 5xyz. And that's it. I'm done. All right, let's go ahead and take a look at the expanding going the other way. Notice number 6 is crossed off. We're not doing that one, okay? All right, so number 1, expand it. Well, I only have one number there, so we're going to break it up into a factor pair. Never use 1 and itself because log base 3 of 1 is 0, so you're really just rewriting the problem. So we're going to do log base 3 of 3 and log base 3 of 9. Now, first of all, log base 3 of 27 can be simplified. 3 to the x equals 27. What does x equal? 3. 3 cubed is 27. So we're going to look at how to rewrite that. Log base 3 of 3 should give me 1. This is 2. 3 squared equals 9. So I have 1 plus 2 equals 3. Not all of them are going to be able to simplify down to one whole number. But if they can, we need to do that. So we got to look for those easier numbers to work with. And if you recognize that from the get-go, you could have just done that. But it did say expand, so sorry. All right, so log base 3 of 4x is log base 3 of 4 plus log base 3 of x. Just writing it as 2 logs. All right, number 3 is not a product property. It's not multiplying, it's dividing. So we'll take a look at that next. All right, let's go back to the notes. All right, the quotient property. The quotient property is saying when it's written as one log with division, you can break it down and write it as 2 logs with subtraction. Those are equivalent, okay? So if you have log base b, log base 2 of, let's say, 9 over 5. That is the same thing as log base 2 of 9 minus log base 2 of 5. And let me show you. Right now I can't do anything there, 9 and 5, base 2, whatever. So if I type in and I'm going to have to do, I can do a base change or I can just use that magical button because it's base 2, okay? So if I go and I do math, go up to A, I've got log base 2 of 9/5. Okay, so if I do log base 2 of 9, minus log base 2 of 5, I should get the same exact answer. And I do. Okay, so they do work out, just so you know. So writing it as one log with division can be written as 2 logs as subtracting. So going back over here, let's go ahead and we're going to condense first, write it as one log. So this would be log base 3 of 24 over 8. Can I simplify? Yes, that's log base 3 of 3, which, hey, wait, that's just 1. Number 5, I can write as log base 2 of 8x over 4x, which when I reduce is just log base 2 of 2, which is 1. They're not all going to simplify to 1, okay? This one is log base 10 of 8 minus log base 10 of 6. So I've got log of 8 divided by 6, or log of 4/3. Okay, remember, you don't need to write that 10 in as the base. Okay, let's go ahead and take a look at the bottom for the expanding part. So here, this one would be log base 3 of 2 minus log base 3 of 3. Well, this can be simplified, so it's log base 3 of 2 minus 1. Number 4 is just log of c, log base 10 of c, minus log base 10 of 6. Nothing else I can do. All right, and then our last property is going to be our product property. What this one states is that if you have a log where the number is raised to an exponent, that's the same thing as if the exponent went in front of it. And this will help us a lot when we are combining, condensing, expanding, and solving, all that good stuff. Okay, so if I have log base 2 of x to the 4th, that is the same thing. That's on condensed form. That is the same sorry, as if I had 4 log base 2 of x. Okay, you can type them in your calculator and get the same thing. All right. So let's go ahead and do some practice. So in number 7, condense it. Oh, I can't see under my writing. Okay, so this is just going to be log base 4 of 2 to the 5th. If you can do anything, do it. I can do 2 to the 5th. So that's log base 4 of 2 to the 5th is 32. I can't write 4 as a power of 32, so I'm done there. This one, it's log 64 to the 1/3. I can take the cube root of 64, so this is log base 10 of 4. And number 9, log base 3 of x to the 6th. I can't do anything with x to the 6th, so that's it. Right, and then going the other way, we only have one example. Taking it and putting it in front. Okay, so I have 5 of log base 3 to the 4. All right, so now we're going to combine them together. Okay. In number 10. All right, number 10. Take care of the product property first. So I'm going to rewrite this 2 as a squared. So I've got log base 3 of 27 minus log base 3. There's a couple different ways you could do this. Squared. Okay. That's log base 3 of 27 minus log base 3 of 9. Right? Because 3 squared is 9. So now I've got the quotient property because it's a minus sign. So this is log base 3 of 27 over 9. Can I reduce that? Yes. Log base 3 of 3, which is 1. Now you may have also noticed, hey, this is 1 right here, so that's just 2 times 1. And then simplify this and combine them. Okay, so there's a couple different ways you could have looked at it. All right, my next one, I'm going to take care of this 1/2 first. So I've got log, I should make these boxes bigger, sorry. 48 plus log base 4 of 3. How did I get that 3? I did 9 to the 1/2 because I used the product property and wrote it as the exponent, and 9 to the 1/2 is saying, hey, take the square root of 9, which is 3. So now there's a plus sign, so I'm going to multiply. So log base 4, 48 times 3 is 144. And that's all I can do. I can't write 4 as a power to get to 144. All right, number 12 is a doozy. I want you to pause the video and try it. Give it a shot. I'm going to work it out right here, but I want you to see if you can come up with it first. Pause it. The answer is -1/2. Let's see if we got that. Okay, so I can rewrite these both as fractional exponents, which is just a square root. So when I'm simplifying them, I might want to see them in square root option. Okay, but it's subtraction, so I can write it as division. I know that sounded weird, but when I reduce that, I can divide both these by 15. Okay, so I just have 1 over the square root of 5. Rationalize that denominator. Now let's put it back as fractional exponents. Okay, this is 5 to the 1/2. Common base, so I can do 1/2 minus 1, which gives me 5 to the -1/2. Okay, and if I were to simplify that, which I can, because I can do 5 to the negative base to the exponent equals 5 to the first, or 5 to the x, what we're trying to find is -1/2. All right, so it's like a big puzzle, guys. That's why I like these. It's a big puzzle. You need to think. You need to take those 3 powers and work your way through it, okay? All right, so number 7 through 12, we are going to be expanding, but same thing. I want you to try to work your way through them on your own. So I'm going to pause the video and I'm going to show the answers, okay? Pause. Unpause. Just letting you know there's multiple different ways and ways you can go. So If your work ends up looking a little different than mine, that's okay. Let's just look at your answers. Unpause. Wait, no repause. I'm confused. All right, take a look. So you can see I did them each in different colors. So you can see 7 through 9 on here. All right, I'm going to go and I'm going to scroll down. I want you to check your answers. If you do have questions, come to me to keep this video not super long. I'll let you look through the work and then come in with questions, all right? So if you need to pause the video to keep looking at these, that's fine. I'm just going to scroll it down now so you can also pause at the end and look at 11 and 12. All right, so when you're expanding it, I will say when it's expanded, there should be no exponents. Okay, those should be moved to be coefficients, and there should be nothing more than one different base in each log. Okay, so it should not be like in number 12, the A and B should not be written together. All right, now the graphing will be its own separate video. It'll be much shorter, its own separate video. All right, adios.